apology is for my voice. I've been struggling with a cold the past week, so my voice is not all that it should be. And then the second apology is that as I was preparing for this conference, I realized that perhaps, as we discussed in the presentation before, my eyes were bigger than my stomach, and this is quite, excuse me, quite a huge topic. And I think it's nearly impossible to cover everything in the 15 or 20 minutes that are given, so I do apologize for the the brief nature of these very detailed topics. And I have an outline that is being passed around, which I hope will help to give some order and structure, and maybe to clarify some of the things that I won't be able to say myself. I'm by no means an expert in the field of string physics. Obviously, I'm in literature, and I'm not a physicist of any kind. However, there's something about string theory that really grabs my imagination, and I really found a lot of connecting points and foundational principles that I think we, as experts in the field of literature, can relate to very easily, without going too much into the technical details of string theory and the physics of it. But we do need to have at least a basic working knowledge of what string theory is, or what M theory is, before we get into the literature part of it. So for our purposes, I just want to make a very mundane comparison. I have 2 children, and there are 2 things that they really like to do. They like to make crafts out of beads using lanyard string. And one of the things that I especially dislike about this activity is when all the beads scatter everywhere on the floor, and I have to pick up every single tiny bead and put it back into the correct bag according to color. And then another activity that they particularly enjoy is either taking a skein of yarn or a roll of lanyard string and wrapping up the house. So going around and around until the whole house is wrapped up in this yarn or in this lanyard. Now, this activity is not quite as intimidating to clean up, because I just have to find the end of the skein of yarn or the end of the roll of lanyard, and I roll and roll and roll until everything comes together. So this is just a very simple way to introduce us to the dilemma that physicists were facing and are still facing in trying to harmonize quantum physics and general relativity. Both of these theories came into being at the beginning of the 20th century, and they know, we know from several experiments, that both of these theories work. However, one of them, quantum physics, only works on a very minute scale, and the other one explains the vast expanses of the universe. But when they try to bring the 2 together, there's a conflict. They can't figure out how to harmonize the 2. Where is the meeting point? So basically, that's where string theory steps in. And if we want to go back to our mundane example, it would be a little bit like as if while I was picking up all the little beads, discovered that they were not tiny individual beads, but that they were in fact connected to the lanyard string by very, very thin strands of gossamer. And of course, this would make my task much easier in trying to gather them up and pick them up, because it would mean that they are not, in fact, tiny little individual entities, but they're all intimately, ultimately connected. And basically, string theory proposes that not only are the beads connected to the lanyard, but the beads themselves are made up of this tightly wound gossamer. So basically they can be unwound and unwound and unwound, and they're all connected. And even the lanyard itself, which they are connected to, is also made of these strands of gossamer. So everything is ultimately connected. Now, of course, in my task of making order, I can look and stand aghast at this tangled mess that I have before me, or else I can be thankful that ultimately everything is going to pull together into one. And for now, physicists have chosen the latter option. Although string theory is currently not experimentally verifiable, it does help at least give them a theoretical framework for explaining a lot of things that were up until now unexplainable, and allows them to pull a lot of things together. Okay, so is M theory the same as string theory? Only in the sense that a letter can be a word. So string theory is part of M theory. For a long time, physicists have had 5 string theories, and the differences between them are so subtle that it's not even worth mentioning. But basically, they thought they were 5 different paradigms, and now they've come to the realization that basically they are just like 5 different windows looking onto the same reality. So M theory includes all of these 5 string theories, and it also includes something called 11-dimensional gravity. Okay? So basically this M theory, since it includes all these string theories and 11-dimensional gravity, they call it their theory of everything. They hope that it will one day be able to explain all of the natural reality that we experience and that we see. And I think it was this theory of everything that really caught my attention, because if it is a theory of everything, then its principles must equally be applicable to all of reality, to everything that we experience, every discipline, every field of study. And everything I know about string theory comes from Brian Greene's book, The Elegant Universe. And I'm going to quote him now. He says, "The ultimate theory should take the form that it does because it is the unique explanatory framework capable of describing the universe without running up against any internal inconsistencies or logical absurdities. Such a theory would declare that things are the way they are because they have to be that way. Establishing such inevitability in the structure of the universe would take us a long way toward coming to grips with some of the deepest questions of the ages." End of quote. So as physicists have found that string theory and subsequently M theory are able to account for otherwise inexplicable occurrences and anomalies in the natural world, I have also found uncanny parallels between some of its foundational truths and ideas, which come to play a vital role in the works of Dostoevsky, Annette von Droste-Hülshoff, and Georges Bernanos. So I have, basically there are these 6 principles which I think are shared between string theory and these writers. And unfortunately, because of the time, I think we'll only have time just to cover one of them. And the first one is, we cannot know one thing absolutely without eradicating our knowledge of another. So, so briefly, just how does this come to play in string theory or in physics? Well, it all started when Planck and Einstein discovered the wave-particle duality of light. So basically, they established that that light is neither a wave or a particle, but it incorporates properties of both. And we cannot understand it in just an either-or sort of way. And then it was the Frenchman, Louis de Broglie, who suggested that this wave-particle duality does not only apply to light, but it applies also to matter. So matter is also made up of not just particles, but waves as well. And then it was the German physicist Max Born in 1926 who asserted that an electron wave must be interpreted from the standpoint of probability. And this led Werner Heisenberg to formulate his uncertainty principle in 1927, which describes the impossibility of knowing both the precise location and the velocity of a particle simultaneously. So, in other words, it's impossible for us to know exactly the place and the speed at which an electron is traveling, because, of course, necessarily if we know one, then it makes our knowledge of the other that much less precise. So we can't really nail it down. Okay? So how can we see this principle at work in the writings of Dostoevsky, Droste, and Bernanos? Let's begin with The Jew's Beach by Droste. Droste notoriously concluded her short novella in a very ambiguous manner, leaving the identity of the murderer a mystery. 28 years after the murder of a Jew named Aaron and the disappearance of both Friedrich Mergel, the prime suspect in the case, as well as Johannes Niemann, his shadowy double and protege, a man returns home to the village from Turkish captivity. He is at first taken for Niemann and indeed claims to be that man, reporting that he was long ago separated from Mergel in battle. Yet a few days later, when his corpse is found hanging from the same beech tree, which was the site of Aaron's murder, the landowner declares him, in actual fact, to be Friedrich Mergel, saying